Okay, finding z-scores and related probabilities for non-standard deviation multiples. So 16C and D here. I've left these two the same just so I can point back and forth. Okay, so what we've got to understand at this point is if you want to find what this area is, well, what you could do is switch your integral. So say, for argument, we wanted to know what negative 1.5 z was. Okay, well, we'd have to go from negative infinity to negative 1.5 of this horrible function, integrate it, and then that would tell us our answer. Now, I don't know about you, but that sounds like it'll suck. So, I propose instead that we don't do that, we use calculators for all these always. So, let's do exactly that. Now, how are we going to do that? I'm going to suggest exactly what we've got up here. I've shorthanded it a little bit. I've just realised I've got a lot of extra junk in there, but that's okay. Okay, so we're in Scratchpad or Worksheet, depending on which one you're doing. Okay, menu, probability, number 5 for me, distributions. Now, depending on what we want to do, we've got one of two options, depending on which way around we're doing the question. So, if I said from before, okay, this time I want to find the probability that z is less than 1. Well, we already know roughly what that's going to be. Because we know that's 34, so it must be roughly 16%. But remember, that's roughly. So let's try and get something a bit more accurate this time. Okay, I want normal CDF for this. That's CDF, not PDF, by the way. Okay, I want to go from my lower bound. Okay, what's the furthest left? Okay, I want from here down, so that's going to keep going to negative infinity, so I'll leave him as that. My upper bound, okay, is negative 1, done. My mu, well, I'm talking about z-scores, so mu must be 0, and standard deviation must be 1, which I think are the defaults in there. Beautiful, that gives us 0.1586, some garbage number. So, put that in, roughly equals 0.158655, garbage, 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 garbage. Very commonly, they'll ask you for 4 decimal places on this, so you round accordingly, but that's rough. Now, is that 16%? It's pretty close, 15.86, etc. Close to 16, so it's an okay approximation. Okay, what else have we got? Well, what if we wanted between some crap numbers instead? Alright, well, that's somewhere around here to somewhere around there, okay? Well, we can just run the same process. You could go through all the menus or you can just scroll up. The first argument is your lower bound. The second argument is your upper bound. So we need to change those. First argument is now negative 1/2. Second argument is 3/2, yep. We're still talking about z-scores, so the 0 and the 1 are going to stay the same. Gives us some terrible number. Roughly 0.624. 655 again. Am I looking at the right line? Oh, they got the same ending. There you go. Oh, close to the same ending. Yep, there we go. Beautiful. So we get some terrible number. Now, at this point, it's less clear if we're right, because we knew that this should be roughly 16%, but this one, we don't know roughly what that should be. So we should consult our drawings and go, alright, I need to go from negative 1/2 up to 3/2, so around here. Alright, well, if I consider from negative 1 to positive 1, that's the same horizontal distance. If I shift over here, I'm going to be gaining, what colour I'll do this, do it in pink. I'd be gaining, my finger gets too full. So I'm shifting to here now, okay. Well, that means that I would lose all of this area and only gain this much area. So I should expect that it's less than all of this. This is 68, okay? I ended up with 62. So yeah, that seems like it's getting pretty similar sort of results, but it's definitely less. So that gives us some confidence that that's okay. Now sometimes you'll get such terrible numbers here that it'll be really difficult to make an estimate, but generally you should be able to tell at least to a multiple of, hopefully a multiple of 10%, worst case a multiple of 25. Until it gets super, super small. And then you're going to struggle a bit, but that's okay. Then hopefully by that point you've already got enough trust that you're typing it in correctly. Cool, alright, what about something like this? Okay, we've got an x variable now, okay? So we're asking what's the probability of a random student getting a study score of 40 or higher, mean 30, standard deviation 7. Okay, well, let's think about that for a second. Well, we know this relationship from before, so we could change it into that if you wanted to. So we'll do that, because commonly that's something that they'll ask you to do. So we've got z-score of interest is that what I wanted, 40? Yep. 40 minus mu over 7, which we know from before was 10 on 7. I want x to be bigger than this, and this is positive 7. Therefore, this is equivalent to asking what's the probability of z being greater than or equal to 10 on 7. Keep in mind the equals won't actually do anything. Okay, so normal CDF. The lower, so the first argument, okay, is 10 on 7. Second argument is infinity, which is under the special, so the pi button's got infinity in there. 0 and 1 for the arguments, yes. So 7.656. 7.656. 7.656. So roughly that. Okay, great. Well, hang on a second. We could have gone the other way around. We could have said, instead of this, we could have said, hang on, why don't I just do something along the lines of just playing around with this so that my initial things all line up in the first place. So I can go back to normal CDF and go, hang on, what I wanted was 40 going up to infinity when my when my mean was 30 and my standard deviation was 7. That gives me the same result, hopefully unsurprisingly. So we could do that as well. That's fine. You can go either way. Totally fine. Doesn't matter. Cool. We never said an inverse question. Oops. Okay. What score would let's say the top 25% get? Okay. So now we know the percentage, but we want to know what that score relates to. So now we're going to have to use the inverse normal to do that. Alright, we want to know the top 25%. Now there's a slight problem here. So we'll go through again. Probability, distributions, inverse normal. It asks us for the area. Now, what we should always do with these things is draw a picture. I want to get the top 25%, so that's somewhere over here. Okay, well, top 25%. This thing says area. Well, should I put in 0.25? If we do that, the way the calculator always counts is from the left. So when we're doing the top 25%, we actually want to tell it the area is 0.75 so that it counts from the left. So 0.75, our mean is 30, our standard deviation was 7. Bang, gives us 34.7-ish. Cool. So the top quarter will get almost 35 as a raw study score. Fantastic. So that's basically it. For the most part, the thing that will get you into trouble is if you don't draw a picture and start drawing in, okay, I want from here up. Doesn't take much of a picture, it's just a quick sketch just to get your bearings, and so that you make sure that you're definitely counting from the left if you're doing an inverse, and so that you know that if you've done any dumb typos or anything, the numbers that spit out, you can go, yeah, that looks like it's about that sort of amount of the area. So it's actually a surprisingly easy thing, and the only other thing to watch out for is Z versus X, just keep track. Other than that, it's a pretty straightforward and easy thing. But if you do have troubles, do let me know, otherwise cheerio.